people tend to suffer from Parkinson's disease. Of course, that number is really low because Parkinson's disease is easily diagnosed in elderly patients. But a lot of people suffer from Parkinson's disease that are younger patients. So if you're 29, it's really hard to detect if you have Parkinson's disease or not. So the disease, you tend to actually live longer with it before you're aware of it. So there's a need to have early diagnosis or early detection of Parkinson's disease. My project focuses on an enzyme called beta-glucocerebrosidase. Now, you don't have to remember that name. You can just remember GCase. That's the enzyme that I'm working on. And this enzyme has been shown to have a lot of correlation with Parkinson's disease and other neurological disorders in the brain. How does this enzyme work? Normally, in healthy human beings, this enzyme has the starting material, that is the squiggly line there. There's a lot of biodegradation of this enzyme to give different products. But in mutated enzymes, so when this enzyme is deficient in people, there is no degradation of the substrate. So you have a lot of bioaccumulation or bioaggregation of your substrate. That's why you have many squiggly lines. And when you have bioaggregation of your substrate or your starting material, it leads to a lot of neurotoxicity. And Parkinson's disease is just one of the diseases that are associated with neurotoxicity. So in my project, we want to be able to study this enzyme, right? Because this enzyme, like I said, is related to Parkinson and other neurological disorders. We're using different techniques to study this enzyme. One of them is radio labeling. So Roland talked about radio waves. It's different from radio labeling, but the common thing is that you have a signal that is detected. So we want to put radio tracers like fluorine, but radioactive fluorine 18 to a molecule, a small molecule, and we want to be able to bind it to the enzyme through chemical interactions that happens in the body. So when we have a compound that has a radio tag on it, injected to a cell that has deficient enzyme, we can track in vivo where the enzyme is, the biodistribution, bioavailability, so that we can have more information of what it's actually doing in the body. We've used computational modeling, as you can see the little picture on the right, to detect what the active site of the enzyme is. So the active site is the region of the enzyme that has a lot of chemistry, that does the chemistry that we're interested in. So if we have a picture of the active site, we can design compounds that are not only specific, but also selective to the active site, so we can have lots of modification that are specific to our enzyme. The reason why this project is really interesting is because we get to use a lot of different techniques. We get to use radio labeling, we get to use synthetic chemistry, but also biological evaluation to solve this complex problem. Now we're not solving the problem of Parkinson's disease, but we're trying to understand what the enzyme is doing in the body. Thank you.